Welcome back to Train Signal Citrix XenApp Training. You're watching Advanced Farm Administration Part 1. So by now you should be a really good XenApp administrator, even an architect. In this lesson, we're going to make you better. So we're going to start off by talking about some advanced zones topics. We're then going to move on to, how do we handle CPU management a little better than the way XenApp handles it? Today, if you log on to XenApp, if you have 10 users or 20 users, whatever the case is, these users can use the CPU and the memory for that matter, however way they like. So one user can be running AutoCAD and consuming 90% of the CPU, while another user is running Word and consuming 2% of the CPU or 1% of the CPU. So you can very quickly see how it can become skewed and how the users aren't getting fair access to the CPU, and performance can be hindered in some instances. So we're going to talk about CPU management, we're going to talk about memory optimization, and we're also going to talk about health monitoring and recovery, HMR. So what that allows you to do, and I don't necessarily agree with how Citrix has implemented this, but this is a method by which Citrix runs internal tests against some important services, some important functions within the XenApp server to determine if these services are still functioning, if they're still delivering services to the users. And if they're not, what recovery methods you can take, what recovery actions you can take against these services to bring them back into a fully functional state. We're going to talk about reboot schedules. Now, for those of you that have been around XenApp and MetaFrame and Presentation Server for a long time, you know that the reboot schedule is almost like a best practice. There's something about rebooting a Windows box. No matter how well the environment is built, no matter how well and fine-tuned your Windows machine is, because this is a server that has multiple users concurrently logging onto it and loading DLLs for different applications in memory, it enhances the performance of the server if you put it on a reboot schedule, so that after that reboot it flushes everything in memory, flushes everything, and just brings back the server in a cleaner way and allows users to log on to it where everything is fresh. It performs better. So I'll show you how to tweak the reboot schedule as well. And then we'll talk about hotfix management. Now again, this is another one of those tools that Citrix has that I don't necessarily like how it's implemented, but I'm going to show it to you and you guys make your own conclusions on that. Hotfix management, the title's a little tricky, so it doesn't really deal with how you deploy hotfixes to Citrix XenApp servers. It deals more with informing you which hotfixes are installed on which servers, so that if you find that a certain hotfix is missing from a server, you can very quickly apply that hotfix and bring the server up to a minimum standard that you're enforcing within the farm. So I'll show you how we can take a look at that. Now, power and capacity management, PCM, I'm only including this topic here for those of you that are going to take the CCA exam. This will be less than 3% of the questions that are coming up on the CCA exam. To be honest with you, in all my experience with XenApp, I have never installed and used power and capacity management in production. But I wanted to cover that just in case you come across some of these questions in the test, so at least you know what it is. But from a practical standpoint, I don't really think you'll ever use it. What power and capacity management allows you to do is, let's say you have a very large farm, hundreds of servers. And for giggles, that farm is in Chicago. And you know that, between the hours of 10 p.m. and 6 o'clock in the morning, nobody's logged on, or very few users are going to be logged on to XenApp servers or using resources. What power and capacity management does is it will try to condense the users onto smaller numbers of servers. So let's say you have 100 users on 100 servers. That's almost a one-to-one relationship between a user and a server. What it will do is it will take these 100 users and maybe condense them onto 5 servers and maybe power down 95%, or 95 servers will be powered down until, let's say, 4 o'clock in the morning the next day, where it starts to power on these servers again in order to allow users to connect to it, because you'll have more users the next morning. Now, I can already see some of the heads nodding and saying, no way I am going to buy into this level of automation. Now, this is not necessarily a bad thing with an automation perspective. It's actually a good thing. It's just, in my opinion, a little difficult, a little problematic in a XenApp environment. Now, with vSphere and Zen Server and those hypervisors, you have that capability as well, distributed power management, where you're powering down ESX hosts and Zen servers, etc. But with them, it's easy. And the reason it's easy is because there's vMotion and ZenMotion and Live Migrate, right? So if you have 10 servers there with VMs on them, you can very easily live migrate those VMs, condense them on a number of servers, and power down the others. Well, you can't do that in a XenApp environment. You can't take a session that's on XenApp 1, XenApp XA01, and live migrate that session from XA01 to XA02 so you can power it down. So the time slice, the time frame it needs to move the users from the servers they're on onto other servers by just disabling logons to certain servers and hope users that are connecting will go to the other. It's just, it doesn't click. It doesn't really, I've never actually seen it work. It takes a long time for this thing to work. It wouldn't work in a matter of hours. It would take maybe days to be able to condense that. So it's a nice to have, but it doesn't necessarily work. It works, but it's not functional. It's not a practical approach to how you would do things. But I wanted you to know that it's available, so that if it comes up on the test, you know where it is. It's outside of the scope of what we're covering, but I'll show you where you can go to install and configure it. So advanced zone topics. So we've been talking about zones throughout this training course. And I want to bring up a graph in a little bit that I've shown you in other lessons, but I want to reiterate here. Data collectors, and let's go ahead and bring up that other graph just so I can show you what I'm talking about. So every zone has a number of XenApp servers. Now, as I've mentioned before in earlier lessons, zones are typically created so you can group geographically close XenApp servers in the same zone. So if you have a zone in Chicago, you put all the Chicago servers in that zone. If you have a zone in Las Vegas, you would put all the Las Vegas servers into that zone. And you can get more granular. In Chicago, if you have 2 data centers and each data center has XenApp servers, then you would have Chicago A and Chicago B, and each one of those zones would have the local physical XenApp servers. And the reason behind zones is that so you can localize traffic. You want to localize IMA traffic to that particular zone. So if you have 2 zones in Chicago, you don't want these zones to be talking to each other across a WAN link. You want those zones to talk to each other locally in the same zone. However, there comes a time when zones need to share data. They need to share the user load. They need to share statistics. They need to share anything that's dynamic, that's related to that particular farm. They need to be able to share it. Now, without zones or data collectors, what would happen is every one of the metaframes or XenApp servers, would communicate with each other. By having a data collector, then you're saying this particular server will always communicate to its counterpart in zone 2 and share the information that it needs to share. Now, in very large Citrix XenApp deployments, hundreds of servers, you might have a XenApp server whose sole role is to be a data collector. It never serves up applications, nothing. It's just there to share the data collector role with the other zones. Now, what we're going to talk about is, well, how do I force a particular server to always become the data collector? How do I rig that? Because an election happens to determine, well, which server is going to be the data collector. The data collector isn't another additional piece of software that you install. There's nothing special about it. It might be a beefier server, maybe a little more RAM, maybe a little more CPU, just to handle the extra function that you're asking the data collector to be. Now, when you're asking the data collector to do more, you want to be able to specify which one of my XenApp servers is a data collector. Now, technically, any one of the XenApp servers can be a data collector. There's nothing that would stop it. And in the event that a data collector fails, an election is held to have another XenApp server become the data collector. Now, every so often, an election is held, again, to elect a data collector. What we're going to try to show you is how do you rig that election? How do you specify one XenApp server to be more preferred than others in taking care or tackling the role of a data collector? So let me go back to that earlier slide for a second. So we're going to talk about how you can set the election preferences for data collectors. And then we're going to talk about, well, how do you assign XenApp servers to zones? Now, by default, when you're installing XenApp, when we went through that exercise, you saw that there was a place where you can assign a server to a zone, or you can create a zone if you wanted to. What I'm going to show you now is, well, if you wanted to move servers between zones, where do you go about doing that? Then we're going to talk about worker group preferences and failover policy. Now, for those of you that are familiar with XenApp, you'll know that this used to be zone preference and failover policy. Let me go back to my graph for a second here. Now, in earlier days of XenApp, there was a need to point a user to a particular zone based on the IP that they have at the time. So if a user is in Hong Kong and they're getting the Hong Kong IP address, I wanted to be able to point that user to the Hong Kong zone. If the user was in Vegas, they're getting a Vegas IP address, I want to point them to the Las Vegas zone. Now, this quickly became very difficult to manage because, again, you could have multiple, you'll need multiple zones. If you're in Hong Kong, you have 2 data centers or 3 data centers. In Chicago, the same thing. It was very difficult because the number of zones grew and the management of the zones grew. So what Citrix did is it broke off zones and created workgroup. So a zone right now, its sole purpose is to group geographically located XenApp servers, whereas worker groups, you can have a collection of XenApp servers that serve a function. You can have a collection of XenApp servers that are based on a particular application. They're application siloed, and thereby you want to be able to send the user or configure the user to connect to that particular work group depending on the IP address that the user is coming from. So again, the concept of zone preference and failover policy has been replaced with worker group preference failover policy, and I'm going to show you where you can go to configure that as well. Now, after zones, what we're going to talk about is CPU management. Now, as I was telling you during the introduction, today, if you don't configure CPU management, the way XenApp treats it is any user can grab as much CPU resources or as much memory resources as they need or as they want or as the application that they're using dictates. Now, in most instances, that won't be very fair to the users because you'll have, you have multiple users concurrently connecting to that server. If one user is consuming 90% of the CPU, then 10% of the CPU is going to be divided among, or is going to be available to the other 9 that are connecting to that server. That's not very fair, and that will hinder performance, and you're going to start getting all these help desk calls. So one of the things that you can do is you can implement what's known as fair sharing of CPU between sessions, which means that if 10 users are logging onto a XenApp server or 20 users are logging onto a XenApp server, one user can't consume 90% of the CPU while the others share the remainder. It will divide the CPU resources equally, as much as possible equally, among the users that are connecting, among the sessions that are connected to this particular XenApp server. Now, another way of doing that would be a little more skewed. Maybe you don't want to share the CPU resources equally. Maybe you want to give preferential load balancing. You want a particular application, when a particular user is using it, to get more access to the CPU cycles on the server. Maybe there are more applications that are more important than others. Well, how do you determine that? There's got to be a numerical value, a certain calculation that you can do, an algorithm by which you can determine that. And we're going to revisit some sessions, some portions of the Delivery Services Console that what we went over very quickly in earlier lessons that are going to make more sense now. So if you wanted a particular application to have more access to the CPU when a particular user is using it, then I'm going to show you how you can do that. What that means is we're going to base that on the application importance, and we're also going to base that on the session importance, and we're going to come up with a number. That number is going to determine the access to the CPU that that particular session and that particular application is going to get. Now let me show you a table here. This is how it's going to be determined. This is the resource allotment calculation. So applications and sessions, for that matter, are categorized as low, normal, or high. Low is 1, normal is 2, high is 3. That's the numerical value that it gets. And the same for session importance. It's going to be either low, normal, and high. And session importance, by the way, is set in the user policy, and I'll show you how to do that. Now, the way to determine how much this particular combination is going to get in, as far as access to the CPU cycles or access to the CPU slices, is you're going to take the application importance and you're going to multiply that by the session importance, and you're going to get your resource allotment calculation or total here. So if you have an application that's set, Windows, let's say Acrobat Reader is set to normal as far as an importance of the application, and the session that's connecting is low, and then the resource allotment is going to get 2 as far as an access to the CPU is concerned. However, if you have Microsoft Word, for instance, and the importance of the application is high, which is 3, and the user, let's say the user is also high, which is another 3, then you're getting 9 is the resource allotment, and you get more and better access to the CPU that way. And I'm going to show you how you can tweak that. This is some cool stuff here. All right, let's get on our XenApp server and configure all these things. All right, so we're back on our XenApp server, XA01, and we're in the Delivery Services console. I'm going to expand the farm here. Now, when we were installing XenApp or XA01, we created a new zone, 192.168.1.0. Now, when I installed XA02, even though it was the same exact process, same exact thing, I put XA02 in the default zone for a reason, so that I can show you this example. So if we go on 192.168.1.0, you'll notice that we have the XA01 server, and under the default zone, you have XA02. Now, if you wanted to move those or reorganize your XenApp servers into the same farm, all you'd have to do is right-click XA02, for instance, and we're going to go click on Change Servers Zone Membership. Now, because this is the only server in this particular zone, as soon as I move it out, and it's giving you a warning here that be careful, this is the only server in the zone, and if you remove it, it's going to actually delete the zone because there's no point and there's no reason for it to exist anymore. So I'm going to click on Yes here, and then I get to choose where I want to move XA02 to. This is the only zone that I have that I can move it to. So as soon as I click on OK here, it's going to give you this particular error because you've lost the zone, etc. If you click on OK here, and if we click on the zone again, you'll notice that voila, it has just moved the servers into the same zone. Now, XA02 got the most preferred server immediately, whereas XA01 is the default preference. Now, these preferences are what determine which one of the servers in the zone are going to become the data collector for that zone. So in order for you to rig the election, and that is determined via an election, so the servers are going to communicate amongst each other, and one of the servers is going to say, I'm going to become data collector based on a different number of criteria. Maybe it has better patches, maybe it has more patches, a higher feature release, a service pack. So based on a number of criteria, one of the servers will become the data collector for the farm. However, in some instances, you might not want certain servers to be data collectors, or you might want certain other servers to become data collectors because it's such a big farm and you want a particular XenApp server dedicated to being the data collector. In that case, you can change the election preference to increase the odds of a particular server of becoming the data collector. To do that, we're going to right-click on XA01, and we're going to set the server zone's election preference. So if I want XA01 to always be the zone's data collector, I'm going to set it to most preferred, and that increases its chances. It's always going to become the data collector if it's the only one that has most preferred. Now, you can have multiple servers that are most preferred, and in that case, there are other criteria that will determine which one of the most preferred servers become data collectors. However, if you only have one most preferred and then you have preferred, well, then the servers that have the preferred flag are always going to get a few more votes here and there. I'm from Chicago, so we're used to that. So you're going to flag the server with we're preferred here. It gets more chances, more abilities to become the data collector. If it's default, then it's the default, and then if it's not preferred, then it's not preferred in being a data collector unless it's absolutely necessary and all other things or all other servers are enabled, then it'll take that position. So if I click on OK here, And let's say I go ahead and let's right click this and say I want this to be just preferred, or I want this to be the default preference. In this case, what I've done is my XA01 is always going to be the data collector, and in the event that XA01 should become unavailable for a period of time, then at that point XA02 jumps in and becomes the data collector for the farm. Now, when we were talking in the presentation, I also talked to you about worker group preference and failover policies, and where you would address that, and I've shown you that before, but let's go through it real quick again, is under the load balancing policies. If you right click the load balancing policy that we have here today, let's just visit this one more time. We're going to modify the preferences, and just to recap here, we're configuring this policy based on incoming IP addresses. So the client IP address, we're filtering based on client IP address. So if the client meets any of these particular requirements, these IP addresses in this case, then I want you to point them to this particular workgroup. So any user coming from a 192.168, etc., whatever we've configured under client IP address, is going to get this worker group as its preferred worker group. Now you'll notice here I have priorities. So if you add more worker groups with more servers in them, you can increase or decrease the priority so that if this worker group is unavailable, then the second worker group is what the user is going to be directed to automatically. So this is how you can configure work group preference and failover or failback policies. Now that being said, let's focus our attention now on CPU management. We talked in the presentation on how you can configure CPU management so that you're changing the behavior of how users are getting access to the CPU resources on the XenApp server. Now all of that, or most of that, is done under policies. So what I'm going to do here, let's get rid of the zones for a second and let's go ahead and expand policies. First thing you have to do is you have to enable CPU management, and to do that, when you enable CPU management, you're enabling it at the XenApp server level. As a result, you would have to modify the computer policy first. So if we go on, let's go ahead and do it under the CRM policy here. Click on next, and let's scroll down, and I'm going to select memory CPU. The first thing we're going to do is we're going to enable it, which is sort of like the master toggle switch. So if I select add here, you have the option of, well, how do you want to enable it? Again, remember, fair sharing of CPU between sessions means that if you have 20 sessions that are connecting to a XenApp server, they're going to get an equal amount of access time, resources or slices on that particular CPU. So if there's 20 users, 10% each, or some kind of a threshold where they're all getting fair share access to the CPU, and one user isn't consuming 90% where everybody else has to share the remaining 10%. Now that's if you're using fair share. It's very easy, nothing there to configure or do. However, today I'm not really in the mood to do fair share, so what I'm going to do is preferential load balancing. So when you do preferential load balancing, now you have to take into account the application importance and the session importance to figure out what is the resource allotment you're going to give this combination, and that will determine how it gets access to the CPU resources. So once we've enabled that, we're going to go ahead and click on OK. And I'm going to click on next here, and we are going to save this. Now, two things you have to do. First, we have to set the application importance, which is one of the first factors we need in our multiplication, remember? So we're going to do that by expanding the applications node here, and let's go ahead and select one of our applications. Let's say we wanted to do this on WinRAR. I'm going to right click on WinRAR, drag down to properties again, and we're going to point to limits. So remember, under limits you had this drop down for high, normal, or low. This is where you would set the application importance. So let's say you wanted WinRAR to be high. We're going to click on OK here. Now you'd have to go into policies again, except this time we're going to go into the user policy. Now keep in mind, we said application importance times session importance equals the resource allotment. So this particular session, you are applying it, you are filtering it against a subset of users, a type of user, or a category of users. Those users are going to be the second half of that multiplication. So those are the users that are going to get the better access or not to the application. So to do that, we're going to go ahead and edit that. And again, we're going to scroll down here, and we're going to go under server session settings. and you'll see session importance. We're going to go ahead and add, and you'll be able to select what you want this session importance to be, low, normal, high, etc. This is where you can tweak that over here. Now once you're done, we're going to click on save. Bada bing, bada boom, you've just configured CPU management from a preferential standpoint based on application importance and user importance. Now the other thing I wanted to show you is if we go into the policies again and we go into computer, let's take a look at the memory optimization features that we can configure. If we click on edit one more time, and let's go ahead and scroll and select memory and CPU. Same concept sort of the master toggle switch that we configured here for CPU management. You have that for memory optimization down here. So if you click on add, you'll have the option of enabling memory optimization. Pay attention and be careful of how you use memory optimization. Memory optimization can be your friend with some applications. It could be your worst enemy or nightmare in other applications. The way memory optimization works, and I'm going to give you a very basic, very simple example here. If you have 20 users logging on to a XenApp server and launching Microsoft Word or Excel or one of the Office applications, typically, each one of those users is going to load the application-specific DLLs for their session every time that user logs in. So if there's 20 users, there's 20 DLLs that are doing the same thing except for different users being loaded in memory. Now, these DLLs get loaded in memory so that you can modify them and do whatever you need to do to them. What memory optimization does is it's going to go through memory and take a look and say, I got all these DLLs here. I can pretty much consolidate them because they're all doing sort of the same thing. I can go through and consolidate them and not waste all that memory using the same type of tasks. Now, some applications are friendly to that and everything will be fine. You'll get a memory boost, you'll get a good performance boost out of that server. Other applications will not like that and as a result might crash the server or crash the application. So you have to be very, very careful and you have to retest and triple test those applications. Now, once you've enabled memory optimization because you see its value and you've determined that there are other applications that are faulty and that should not use memory optimization, what you can do is you can instruct memory optimization to exclude those applications from being optimized. So what you do is you come in here, click on add, and you add that particular application so that when memory optimization is doing its run, it completely excludes those applications. So again, you'll have to do some testing here in order to figure out which applications are memory optimization compatible and which ones are not, and make sure you specify the ones that are not down here. Now, once you've gone through that, and now it's time to figure out, well, how often do you want to run memory optimization? Because memory optimization it's not running in real time. It has to run based on an interval, based on a schedule of day or month, etc., day of the week. So you can come in here and say, I want this to run daily, for example, and I want this to run on a particular day of the month. You can tweak that once a month maybe, and you can do that on which day of the week. So it's running once a month on Sunday at this interval, etc. And you can also tweak it, schedule the time. So how often, when, what day, what time, etc., etc. This is how you can tweak the memory optimization features of XenApp 6. All right, and since we're still inside of our policies, let's take a look at health monitoring and recovery, HMR. So I talked to you during the presentation about how you can use HMR and why you would use HMR. HMR, again, is designed to monitor specific Citrix services that are vital for the proper functionality of the farm. So the first thing you would need to do is, again, as with all the other things that we've done, is you have a master toggle switch that you would have to enable to instruct the server to start monitoring these services. So if you click on add there, you can enable that particular setting, and then you have the ability of taking a look at what it's monitoring and what to do when it fails, and you do that under health monitoring tests here. So it runs a series of tests. Now, the one thing that I want to point out here is you can't modify those. Like, this is not a PowerShell command that you can add in here to increase the number of tests. These are typically applications that you can download from Citrix or that Citrix will make available that you can add inside of these policies here to run other or additional tests, because you'll notice that if I click on add here, there's really nowhere for me to put a PowerShell or a command or point it to a script or anything like that. So those tests are going to be sort of canned tests that you can add, that Citrix has made available through one form or another. So you can come in here and add any of these particular services that you wish to monitor, and by default you have the following services that are being monitored. So you have the IMA service. It's going to check the IMA service on every 60 seconds or so, and it's going to keep trying for five times before it deems that okay, the Citrix IMA has failed, and then it's going to take action. So again, this is with regards to the IMA service here. It's monitoring the log. Am I able to log on to the server? It's monitoring the XML service, which is very useful or very important, especially if you're using web interface, etc. And then you have terminal services. Is terminal services functioning? Now, for any one of those particular servers or tests here, if you click on edit, you can modify some of the parameters, some of the settings. So here you have the interval in seconds, so it's going to check the IMA every 60 seconds, and you have a timeout value again of 60 seconds. What's the threshold? How many times should I try this before I report that there's a failure? So maybe I tried it the first time and it failed. That doesn't necessarily mean that maybe the IMA service is down. Maybe the timeout value here was too low and the IMA service did respond, except it took more than 60 seconds. So how many times should I try this test? And if it fails, I'm going to take some kind of an action. So here by default you have it set to 5, and you can have any one of those actions. You can alert the administrator, you can remove the server from load balancing, you can shut down the IMA service, you can restart the IMA service, or you can reboot the server. Now, removing the server from load balancing is interesting, and you have to be careful on, well, how many servers do you want to remove from load balancing if the IMA service should fail? If you have 10 servers or 100 servers, what's the percentage of those servers that you want to be able to remove? Now, I'll show you where you can set that setting. It's not here, but I just wanted to make mention of that since it's an option of removing servers. I'm sure you're thinking, well, I don't want to remove all my servers if multiple are having an issue. So once you've determined what you want, you click on OK, you finish this, etc. You can click on OK here, and you can apply that policy. Again, you can add from Citrix, you can add custom, but it's very limited as far as what you can add here. This is information that you would probably get from the Citrix support, or if Citrix is making a particular application ready but it's not part of the GUI, you can install it on the XenApp server and they'll give you the parameters, but there's nothing really from a switching or PowerShell perspective that you can control here. Obviously, you can also remove any of the ones that you don't want to monitor. So I click on OK here. Maximum percent of offline servers. So remember how I told you that you can have servers removed from load balancing? So this option will determine how many servers do you want to remove out or make them offline. So here the value is 10%. So if you have 10 servers and 2 are experiencing that issue, then only one of them will be removed out of the farm, rather than removing both of them, for instance. So this is how you can control that particular setting here. And that's really all there is to it from an HMR perspective on how you can monitor those services or those vital applications that you need to run your farm properly. And the other thing that I talked about in the presentation was reboot schedules, or the reboot behavior as they call it here. So what the reboot schedule does is, again, it will reboot your servers, your XenApp servers, based on an interval. So you want, for whatever reason, again, these are multiple servers that are being accessed frequently. They're accessed all day with multiple users, putting stuff into memory, taking stuff out of memory. So it's a good idea to reboot those servers, if possible, during an outage, at 3 o'clock in the morning, if possible daily, maybe weekly or monthly, whatever it is, just to flush out anything that's stuck there that might be causing the server to not perform the way it should be performing. So this is where the reboot schedule can come into handy. So the first thing you want to do with the reboot is to turn it on, of course, as we've been doing with everything else. And to do that, we're going to scroll down here to scheduled reboots. We're going to click on add, and then you can click on enabled. And voila. Now you've enabled it. Now all of the remaining settings that you have up here are going to deal with, well, what happens after you enable it. Let's start with the top. Reboot custom warning. So this is going to send a warning. Do you want to be able to send a warning to all the users that are connected to your ZenApp server that this server is about to be rebooted in 20 minutes or in 30 minutes, etc.? If you want to be able to send a warning, you want to be able to enable the sending of the warning, the process that, hey, I want to be able to send a warning. So you enable it first, and then you can customize the warning text, the warning message. So for example, if you know that you're rebooting the servers every day at 3 o'clock, and you're going to configure it so that it reboots at 3 o'clock, then the warning message can be like, if it's going to start rebooting 20 or 30 minutes ahead of time, the warning message will be sent to users that, hey, the server is about to be rebooted in 30 minutes. Please save your work and exit the servers, or exit the servers and try to connect again at 3:30. So whatever custom message you want to deliver to your users, you can set the value of that message here, and the server will automatically notify them by sending a message to their session that pops up in front of them and say, hey, the server is about to be rebooted. Now, another thing that you might want to do is reboot logon disable time. So typically, if you're going to put the server on a reboot schedule, you want to be able to disable logons to the server 30 minutes ahead of time or 60 minutes ahead of time. So no new users are connecting to the server, and then you're going to inconvenience them again 30 minutes later by telling them to log out because the server is being rebooted. So this setting here is dealing with, well, at what point do you want to disable logons to the server before the reboot? So you can set the parameter here based on your preference. Reboot schedule frequency. You want to do it 7 days a week? You want to do it once, 1 day a week? What is the frequency of the reboots? Is it every 7 days, every day, every 2 days? This is where you can set that particular value. When is the start date? When do you want to start this schedule? Do you want to start it today? Do you want to start it tomorrow? When should this schedule for reboots be in effect? So you can put the particular value that you require there. And what time? When do you want to do these reboots? At what time of the day should I schedule these reboots to occur at? Let's scroll down here a little bit. What is the warning interval going to look like? So if you click on add here, every 15 minutes it's going to send a warning. Every 3 minutes it'll send a warning. How often do you want it to notify the users that, hey, you need to save your work and get out? This can come in handy. Users don't really listen the first time you tell them to do something. When do you want the warning start time? When do you want it to start warning the users? And then you have the reboot warning to users here, which is just a master toggle switch of enabling or disabling that particular option of notifying the particular users that this is going on or this is happening. And that's it. That's all there is really to it from a reboot behavior perspective. So once you're done, just next it all the way and then save, and it will just basically go into effect. All right, now let's focus our attention on hotfix management. So again, as I've told you before, is hotfix management doesn't really push any hotfixes. It just gives you a mechanism by which you can identify which hotfixes are installed on a particular ZenApp server, or you can maybe compare the hotfixes that are installed on all of the ZenApp servers in your environment against the master list of hotfixes that you support or that you verified and that you want all the ZenApp servers to have. So an easy way of determining if those hotfixes are installed on your ZenApp server or not. So if we click on hotfix management up here and we go to hotfix details, you'll notice that I've installed 2 hotfixes on XA01, and I purposely didn't install them on XA02 so that I can go through this exercise with you guys. Now, first let's go with the naming convention of how Citrix names their hotfixes. This is basically saying it's ZenApp 6 hotfix, Windows Server 2008 R2, x64 of course, and then it says 056. So the hotfix number is 56, and Citrix typically enumerates those numbers, so it goes from 1 all the way up. And it, the higher the number of hotfix doesn't necessarily mean that anything lower than that particular hotfix, all the hotfixes are included. So hotfix 56 doesn't mean that the earlier 55 hotfixes are included within this hotfix. So just pay attention to that. Sometimes it does, sometimes it doesn't. Just make sure you read on the particular specifics of that hotfix. Now here it's telling you which ZenApp server it's installed on, which product, which user installed this particular hotfix. So you'll see here that we have it as the administrator, when it was installed, just information on what type is it? Is it hotfix, rollout pack? What is it? Which version or which language? English, United States, last refreshed, etc., etc. So it gives you a lot of information on the particular hotfix itself. Now, there's a few methods by which you can compare hotfixes to servers. You can create a master list of hotfixes, and you can compare the servers against that list, or you can compare servers against one another. Let's start by creating or taking a look at the master list of hotfixes. Now, if you don't have a hotfix list yet, you would have to create one. You can use any of the shortcut keys here, or you can just right-click Hotfix Management, drag down to Configure Hotfix List, and you can create a new list here. Now, once you're created a list, you can add it. You can if you already have an XML, or if you've downloaded an XML from somebody, you can browse to that XML file, load it up in here. If not, you can select from server hotfixes. So you can say, I want to start off with all the server hotfixes that are on XA01. I want that to be the basis of what's going to populate my list. Or you can do custom and select the hotfix name. You can select any of the existing hotfixes that are in there, etc., etc., and build your list that way. Once you've selected that, you'll be able to save this particular list somewhere on the network, or somewhere where you can get access to it easy. Let's go ahead and do that. Let's say I wanted to do a save as here, and we wanted to put it on the desktop. Let's just leave the name as at the default, and you can click on save. And that's it. That's all there is to it. Now, when you're trying to compare from another server, what you do is you can right-click Hotfix Management here, and you can do Compare to Hotfix List. Once that comes up, you can say, okay, which server do you need to know what hotfixes are on it? Let's say the scope of what we're trying to do is we want to take a look at comparing our XA02 to our master list. You can click on that, click on Next. And if you have a list already, you can select the second option down here, which is select from a list, browse to that particular list, find it, and you can do the comparison that way. Or if you just want to compare it against an existing server in the farm that that you've installed everything that you want on it, you can do that as well. Let's say you do that and select XA01. If we click on Finish here, it's going to display the current hotfixes that are on XA01, and you'll notice here that it says missing hotfixes items, and it'll show you the hotfixes that are not installed on XA02, and gives you at that point all the information that you need in order for you to go and rectify the problem by installing those particular hotfixes against the server that is lacking them. So hotfix management, again, it's very basic. There's really nothing there to see other than this is a mechanism by which you can compare servers against either a master list of hotfixes or against other servers that have all the right hotfixes that you want, and allows you to rectify the situation that way. Now, the last thing I want to talk about in this lesson is power and capacity management, which we discussed in the presentation portion of the lesson. Now, again, I'm only mentioning this because you'll probably see it on the CCA exam, and I want you to understand and know what it does. Typically in real life, you'll probably never ever use this tool. I've never used it, and I've never come across in all my consulting years an environment that's ever used this particular feature. But if you wanted to install it, it has two main components to it. If we go back into the XenApp 6 CD here, and you click on Manually Install Components, and you click on Server Components, you'll see that you have Power and Capacity Management here. Under Power and Capacity Management, you have two options. Any server that is going to participate in the Power and Capacity Management solution, per se, would need the Power and Capacity Management agent to be installed. And you would also have to install the Power and Capacity Management Administration console in order for you to configure all of these settings. Again, I just wanted to show you where it is and what you could do with it. This is strictly for the CCA exam. Going through all the different settings here, very basic, but it's outside of the scope of this particular course, but I wanted you to be aware of it just in case it ever comes up or the topic comes up, so that you know where it is and how it is and what it's used for exactly. All right, let's go ahead and switch back to our presentation and recap what we've learned. So we started off this lesson by talking about advanced zone policies. We talked about how the election happens, how you can set most preferred and default, and what are the advantages of having a data collector and why a data collector is used to sort of become that bridgehead between the different zones so that the different zones within your farm understand what's going on with the other load on the other servers and the statistics and who's logging on where. So we talked about the role of the data collector. We also talked about the worker group preference and failed back policy and how in some instances you might want to be able to direct certain users when they're coming in from a particular IP address to a set of servers, and how if those servers aren't available you can have another set of servers, etc., etc. So we discussed a lot of advanced zones topics, and I showed you how to move servers between zones as well. And then we talked about CPU management. We mentioned that today when you log on to a particular XenApp server without CPU management, any user can take the full CPU to themselves. So if you have 20 users and one user is consuming 90% of the CPU, then that leaves 10% for the rest of the users. We talked about how you could do fair sharing of CPU resources among the sessions that are connecting, or how you can do preferential based on the application importance, the session importance, and you get that load allotment so that you can figure out when a set of circumstances exist, how much that particular application and that particular user will get access to the CPU. We also talked about memory optimization and how today, if you have Word as a published application in your farm and you have 20 users connecting and loading Word, then 20 users will load the same type of DLL files into memory, etc., etc. Memory optimization will go ahead and sort of consolidate them. It's not memory dedupe per se, but the concept is very similar. So we talked about where you would enable it and how you would enable it and how certain applications don't work well with memory optimization and that you would have to be careful in how you exclude those in the Citrix policies. Then we took a look at health monitoring and recovery, HMR, and how you can configure that and turn it on, and which services are being monitored by default, and what can you do, what corrective measures, what tasks can you do if a particular server is deemed unresponsive or down. We then moved on to the reboot schedule. I showed you where in the policies as well you can configure reboot schedules, how you can send messages to users warning them that there's going to be a reboot, how you can disable logons to a particular server in advance so that no new users can connect, etc., etc. So we discussed the reboot schedule in detail there. And we talked about the hotfix management. I explained to you and showed you how hotfix management is a method by which you can compare XenApp servers to either a master list of hotfixes that you've tested that you want to be the hotfix standard in the farm, or you can compare servers against one another if you have a particular server that is configured and that has all the patches that you want. So we went in there and we took a look at that. And finally, we talked about power and capacity management and how power and capacity management is typically used to consolidate users on a smaller number of servers, thereby giving you the ability of powering down the remaining servers so that you can conserve power, etc. But how it doesn't really make a lot of sense, or how it's not really enforced within a XenApp or terminal server model, because there's no real concept of live migrating those sessions that are connecting to particular servers in order to consolidate them. So the only thing that you can do is really wait for the user to log off, and hopefully the user is logging off, not disconnecting, because if they disconnect, then that session is really still running on that server, and as a result, power and capacity management doesn't really know that this is a disconnected session, even though you can set some parameters on, well, if disconnected for X amount of time, disable it or log off, etc. But still, there's no really proactive way of moving those sessions in order to consolidate. So the consolidation, or the way it works, is really convoluted, doesn't really work effectively in short periods of time, and it might take days before this can even take into effect. And because it takes such a long period of time, you miss that window where you need to power down the servers. So if it takes 3 days and you only really need to power down the servers between 10 p.m. and 6 a.m., well, it kind of defeats the purpose. So it's a nice to have. I've never seen it been used, but just in case you're taking the CCA exam and they ask you about that, I wanted to make sure that you guys were aware that that particular feature exists. Finally, I hope this lesson was informative for you, and I'd like to thank you for viewing.